So in this video today, we're going to be talking about finding area, specifically for oblique triangles. So triangles that are not a right triangle. So first off, let's go back to the basics and understand how do you find the area of a rectangle and how do you find the area of a triangle, concepts that you've learned in geometry. Now you're probably thinking, okay, why does Ms. Chang want us to find the area of a rectangle? And soon enough, you will figure out why it is relevant. So first off, let's just draw the shape. I always think that when it comes to mathematics, we need to understand the picture. And so a rectangle is a four-sided shape, 2D shape, with a base and a height. And so if I want to find the area, I need to figure out the base times the height is what we've learned in geometry. So we learned this formula, which is base times height. And then for a triangle, you might have learned before. So if I were to draw a triangle, it's a three-sided shape. And a triangle also has a base. You can consider this bottom side here the base. And the height is always the highest point of the triangle drawn down to the lowest point of the triangle or to the base at a 90-degree angle. And so we refer to this as the height. And you might remember this formula as 1/2 times base times height. Some people also know it as base times height divided by 2. Either way, it's the same. But let's compare these two formulas and you'll start to notice a lot of similarities. Like they both multiply base times height, but this one has a half in it. And I want to understand today with you guys, why is there a half there? Because there is a clear picture when we start to compare a triangle and a rectangle together. So we're going to uncover, why does a area of a triangle have a half here? What is the purpose of that? Versus a rectangle that doesn't have a half in front of the formula. So when we look at the area of these two, they both have the same height. So they both have a height of 3. And they both have a base of 7. So same height, same base. Let's take a look at the triangle first. So the triangle, if I want to find the area, I would just plug it into the formula. So 1/2 base times height. So I would have my base, which is 7, times my height, which is 3. If I plug this into a calculator, I would multiply these two, would get 21, multiply it by a half, is 0.5. So the area here is 10.5. All right, let's do the other one here. So this one is the area of a rectangle, which is base times height. And so this is 7 times 3. And so my area is 21. So when we compare our two answers, this one is obviously half of the result or half of the area of the rectangle. But let's understand why. So when I start to look at this triangle here, I start to notice the bottom is the same measurement as this bottom. So if I were to fill the area around the triangle to make it look like the rectangle over there, let's see what happens. So I'm filling in this triangle to make it look like the rectangle off to the other side. And you guys will start to notice something fishy, right? So I've made a right angle here and here. And if I really think about it, it looks like there are two rectangles here. So I kind of see like this as a rectangle and then this as a rectangle. But piece it together and it's the exact shape here because the height is 3 and the base is 7. So I start to notice, well, if I think of this part as a rectangle, I have half of its triangle here, and this is the other half of the triangle that's missing. This rectangle here is half of it is appearing on the triangle, but the other half is missing. So when you think about it, this triangle is literally half of this rectangle, and you can kind of see it in the drawing. But hopefully that gives you a clear picture of why the area formula for a triangle is always half base times height. Essentially, how I've always told my students is if a triangle and a rectangle both have the same base and height, then the triangle is always half the area of a rectangle. So let's get into today's lesson, which is talking about finding area for an oblique triangle. So oblique triangles just means that they are not a right triangle. So if you don't have a right triangle, it's a little bit more difficult to find the area because you're missing the height. You're essentially missing the height. The beautiful thing about right triangle is because one side is at a 90-degree angle, it's really easy to uncover the height of the triangle because you can use SOHCAHTOA. Like if you have one of the sides or one of the angles, you can use SOHCAHTOA and find the height of the side, and then you can plug it into the area formula, which is 1/2 base times height. But if you're only given the sides of the triangle with an oblique triangle, you still have to go find the height, and that makes it a tiny bit difficult. But no worry, someone has already derived a formula to find the area of a triangle if it is an oblique triangle. Or basically, this works for any triangle in the world, even a right triangle. So essentially, if your triangle is a side angle side, it's recommended to use this formula here because you'll notice this formula has two sides that you can plug in and one angle. So that's why this formula is mainly recommended is if you have two sides and an angle, and the angle is between the two sides. So it says here the area is half the product of the length, two sides, and the sine of the angle between them. So essentially it's describing what this formula entails. So basically if you have an angle and it's two sides next to them, probably use this formula to find the area of the triangle. And we'll practice a lot using this formula. But let me talk to you about the other formula. So what if you don't have an angle, but you have all the sides? In other words, you have an SSS or side triangle. Well, there is something called the Heron's formula. And basically what Heron's formula entails is you have to find something called a semi-perimeter. And a semi-perimeter is where you take up all the sides of a triangle. So let's say here's my triangle. You took all the sides of the triangle and you added it up, as you can see here, and you multiply it by half. So that's what it means by semi-perimeter. So add up the sides, that gives you the perimeter of the triangle, but semi means half, so half the perimeter. Once you have that number, you can plug it into this formula, and basically that S represents that number that you found for the semi-perimeter. And you reuse that, but you're always taking it the difference from each side length. And we'll practice using this formula. So you only want to use this formula here when you have all the sides, because you don't want to use this guy because it's a little bit more inconvenient. You have to find the angle and that might take you a while, whereas this one's already a direct formula if you have all the sides. So one last thing before we get into the practice problems. Down below it says these area formulas are only intended to use when you do not have the triangle's height. Let me iterate why. So most of you guys have learned the formula, and like we mentioned before, the area of a triangle is 1/2 base times height. You should always use this formula when you can. When you have the height and the base, you should always use this formula because it always works for any given triangle. But the problem is you're not always given the height of the triangle, and it might be hard to find the height. So if that's the case, we recommend to use either the area of an oblique triangle, so this formula here that has the signs, or Heron's formula that is used when you have all the sides, all three sides. So let's get into practicing these area formulas. So example 1, start with figuring out what type of triangle you have. I think that helps you tremendously on figuring out which formula to use. So if I were to draw out this triangle here, it looks like we have C is 120 degrees, so it looks like it's an obtuse angle. So I'll try to draw this wider. There we go. And so this is C, it's at 120 degrees. And so C would be right across from it, or little c. And let's say this side here is A4 and this side is B. And so this is 6. Okay, so I'm given 2 of the sides and I'm given the angle. So it becomes really clear that the angle's in the middle and the sides are on the next to the angle. So this is a side angle side. So in this case, if I have a side angle side, if you look at your notes, you probably want to use the area for oblique triangles, the one that has signs in them. Now, you can use any of these 3. You don't have to use all of them, but use the one that you already have everything. So in this case, you have angle C and you only have the sides A and B. So probably we need to use the second equation so we can plug in our sides and plug in the angle that we have. So I'm going to copy and paste that formula here so we can see it together. So the area would be equal to 1/2 A times B sine of C. So my A is 4, my B is 6, and my sine is being plugged in 120 is my angle. So I can go ahead and just plug this all into my calculator in one go. And if I do, I get 10.392 if I round to 3 decimal places. By the way, just a quick tip here. A lot of people, when they plug 1/2 into the calculator, they'll just write this as 0.5. So when I type this in the calculator, I'll just do 0.5 times 4 times 6 times sine of 120. Makes it a little bit easier to write in the calculator. So I get my area, and that's it. It is just as simple as that. So my area is 10.392, and I have a side angle side triangle. All right, next problem. So this one here, again, I'm going to draw a picture to see what type of triangle I have. Looks like I have another obtuse triangle, and this is at 130. I have B, so little b would be right across, so I'll put A here at 92, and C would go right here at 30. So I have 2 sides and 1 angle that's in the middle. So I definitely, again, have another side angle side because the angle's in the middle and the sides are directly next to it. So again, this is going to be using the oblique triangle area. And this time around, I'm given my A and my C, and I'm given angle B, so I probably want to use the third formula. Essentially, the formula basically just takes 2 of the sides and the angle and multiplies them. But you have to make sure all the letters are different. Notice how each of these formula has a different letter that you're plugging in. So whatever your angle is, you should be using the sides that are opposite of it. So in this case, my area formula is going to be the one that's 1/2 A times C, because that's the one I'm given, and times sine of B. So my A is 92, my C is 30, and sine of B, my sine is 130 degrees. So I'm going to plug this into the calculator. So 0.5 times 92 times 30 times sine of 130 is going to give me 1057.141. So I have my area. So in this case, I'll write my answer here. So again, I had another side angle side, and this is 1057.141 as my area. So that's it for this video. In the next video, we'll do the rest of the problems.